Hello students. So students, we are discussing our next topic, that is reactions of metals with acids. Reactions of metals with acid. However, we have done it already in the acid, bases and salt. तो यहाँ पे हमें जो dilute acids हैं उनकी metals के साथ reaction देखनी है. First of all, metals में react with dilute acid, it forms salt and hydrogen. Okay, hydrogen gas is always liberated whenever metal reacts with acid. So some examples are there, like sodium when reacts with HCl it form NaCl and hydrogen gas is liberated. Potassium when react with HCl it form KCl, hydrogen gas is liberated. Magnesium react with HCl form MgCl2, hydrogen gas is liberated. Iron react with HCl it form FeCl3, hydrogen gas is liberated. You can write one more example, like sodium plus H2SO4. Okay, it form Na2SO4 plus H2 gas is liberated. यहाँ सारे example HCl के हैं. We have all taken one example of H2SO4. One more thing, remember that hydrogen gas, this is very important, this note is very important, that hydrogen gas is not evolved when a metal reacts with nitric acid. Okay, these are HCl and H2SO4, but if we take nitric acid, then hydrogen gas will not evolve. Reason is that hydrogen HNO3 is a very good oxidizing agent. Okay, oxidizing agent means which provide oxygen to other elements or atoms. Okay, तो इतना अच्छा ऑक्सीडाइजिंग एजेंट है कि जो इसमें हाइड्रोजन गैस बनेगी उसको ऑक्सीजन प्रोवाइड करके HNO3 क्या करता है, उसको H2O में कन्वर्ट कर सकता है, कर देता है एक्चुअली. सो दैट्स वाई we say that HNO3 does not produce H2 gas while reacting with metals. Okay, a few exceptions are there where hydrogen gas can be liberated. Okay, first of all, the itself get reduced, that is HNO3 get reduced to form N2O, NO or NO2. These are the nitrogen oxides. Then after, magnesium and manganese, these are the metals, when react with dilute HNO3 they evolve hydrogen gas, very dilute. Okay, very dilute means the part of HNO3 is very less. In that case they can evolve hydrogen gas. Okay, but in the normal diluted form H2O will be released. Then after, one more thing, copper does not react with dilute HCl to produce hydrogen gas. Okay, copper reaction नहीं करता किसके साथ, copper है, Ag है, they do not react with acids to form hydrogen gas. ये जो है ये डिसाइड होता है रिएक्टिविटी सीरीज के अकॉर्डिंग, एंड इन दिस वीडियो आई हैव इंक्लूडेड दैट रिएक्टिविटी series. You will see it later. Then after the action, I show you that series right now. See, this is the series, reactivity series. Potassium is the most reactive in these metals, and Au, gold, is the least reactive. And the elements which are below hydrogen, this is hydrogen, they cannot replace hydrogen, or you can say they cannot evolve hydrogen gas by reacting with acid. Okay, so copper जो है वो इससे नीचे है, that means copper will not evolve hydrogen gas while reacting with HCl, or you can say copper does not react with HCl. Okay, ये नीचे वाले नहीं करते, and these metals react with HCl to form acids to form hydrogen gas. Then after, the action of acid on metal depends upon the reactivity of metals. For example, the reactivity of these metals with dilute acid decreases as follows. इसका मतलब ये है कि these are the metals, and whenever they react with HCl, how eagerly, how vigorously they evolve hydrogen gas, that depends upon their reactivity. जितना ज़्यादा reactive होगा उतनी जल्दी, उतनी तेज़ी से क्या होगा, हाइड्रोजन गैस लिबरेट होगी. So you can see in the reactivity series that magnesium is the most reactive, then aluminium, then zinc, then iron. Okay, so they evolve hydrogen accordingly. Then after, reaction of metals with solution of other metals. देखो, अदर जैसे दूसरे मेटल का सोल्यूशन है और उसको किसी एक मेटल से रिएक्शन कराते हैं. सो सच इन सच रिएक्शन वन मेटल डिस्प्लेसेस अनदर मेटल. फॉर एग्जांपल जैसे एंड इट ऑल्सो डिपेंड्स अपॉन द रिएक्टिविटी सीरीज. If the metal which is reacting with the salt solution is more reactive than the metal already present in the salt, then it will replace it. जैसे कि अगर इसमें sodium and potassium, you can see sodium is more reactive than potassium, potassium is more reactive than sodium, so potassium can easily replace it. K plus NaCl, KCl formed and Na is eliminated or liberated. Second, Fe plus CuSO4, you can see Fe is more reactive than copper, so Fe replaces copper, it forms FeSO4 plus Cu. Okay, then after Mg plus CuSO4, magnesium will replace copper, it forms MgSO4 plus Cu. These are some examples in which a more reactive metal replaces the less reactive metals, and such reactions in which more reactive species eliminate, or you can say replace the less reactive species, those reactions are called displacement reactions. Okay, if we do opposite, that means if less reactive metal is reacting with the salt of more reactive metal, then no reaction will take place. Like we have taken, if copper is reacting with FeSO4, no reaction takes place because copper is less reactive than iron. This is the reactivity series. I have already told you that these are the elements, or you can say metals, which are arranged in their according to their reactivity order. That means reactivity is decreasing down. Okay, this is the most reactive and this is the least reactive. This series is called reactivity series. Then after, reaction mechanism of metals and non-metals, how metals and non-metal react. Okay, you know very well metals have extra electron in their electronic configuration and to complete their octet. Okay, and in case of non-metals they have lack of electrons. That means metals require to remove the electrons from them to complete their octet or duplet, and the नॉन मेटल्स नीड सम एक्स्ट्रा इलेक्ट्रॉन टू कंप्लीट देयर ऑक्टेट. एग्जांपल ले सकते हैं हम, जैसे सोडियम जो होता है, सोडियम की कॉन्फ़िगरेशन होती है 11 इलेक्ट्रॉन्स, 2 8 एंड 1. सो इफ दिस एक्स्ट्रा इलेक्ट्रॉन इज रिमूव्ड देन इट विल कंप्लीट इट्स ऑक्टेट. 8 इलेक्ट्रॉन मीन्स ऑक्टेट, तो इसका ऑक्टेट कंप्लीट हो जाता है, सो इट कैन ईजिली लूज इलेक्ट्रॉन. इन केस ऑफ क्लोरीन, its 17 electrons are there, and you can see its electronic configuration as 2 8 and 7. That means to complete its octet, that means 8 electron in outermost shell, it need one extra electron. So the electron that can be eliminated by this sodium will be accepted by this chlorine. Okay, and it form Cl negative 288. If extra electron is added in chlorine, it will get negative charge, and if electron is removed from sodium, it will get positive charge. And whenever they form negative and positive charge, they will attract each other, because this becomes cation and this becomes anion. देखो ये positive charge है, negative charge है, opposite charge always attract each other. इनकी अगर हम configuration की form में लिखे, like sodium, see the valence shell, it has one extra electron, and तो इसमें हमें इस डॉट से 1 इलेक्ट्रॉन शो कर दिया. देन आफ्टर क्लोरीन हैज़ 7 इलेक्ट्रॉन्स इन इट्स आउटरमोस्ट शेल, एंड वी हैव डन इट बाय 1 2 3 4 5 6 एंड 7. अगर तुम बुक में देखोगे तो उसमें क्रॉस लगा रखे, मैटर इज सेम. ओके, दिस बोथ थिंग्स आर सेम. तुम लोग डॉट से भी शो कर सकते हो इसको. एंड क्या होगा, sodium will donate this electron to chlorine and becomes positively charged, and chlorine becomes negatively charged. and जैसे ये इलेक्ट्रॉन इसमें ट्रांसफ़र होगा, सोडियम के पास कोई इलेक्ट्रॉन नहीं रहेगा, और इसके ऊपर 8 इलेक्ट्रॉन्स हो जाएंगे, 1 2 3 4 5 6 7, एंड दिस वन इज 8th इलेक्ट्रॉन. एंड sodium gets positive charge and it gets negative charge, and they will attract each other. Okay, by electrostatic force of attraction, the attraction between two charged particles. And electrostatic force of attraction, remember, is one of the strongest forces in the world. Okay, बहुत strong forces होती हैं. तो इस तरीके से metals and non metals एक दूसरे के साथ react करते हैं. एक और example दे रखा है, magnesium. Magnesium has 2 extra electrons, its configuration is 2 8 and 2, 2 8 and 2, and it loses 2 electrons to get octet 2 electron. Then after, chlorine has the same configuration, it will attract 2 electrons. So if magnesium is providing 2 electrons and one chlorine atom requires only 1 electron, that means to accept these 2 electrons, 2 chlorine atoms will be required, and so magnesium react with 2 chlorine atoms. One of the electron is transferred to first chlorine and second electron to second chlorine, and it form Mg2 positive and Cl2. Okay, it form compound MgCl2. ओके, वेन एवर अ बॉन्ड फॉर्म्ड, दैट मीन्स जैसे जो ये मेटल का नॉन मेटल के साथ रिएक्शन हुई है, वेन एवर अ बॉन्ड फॉर्म्ड जस्ट बाई ट्रांसफरिंग ऑफ इलेक्ट्रॉन फ्रॉम वन एलिमेंट टू अनदर एलिमेंट, देन दैट काइंड ऑफ बॉन्ड इज कॉल्ड आयोनिक बॉन्ड. ओके, आयंस बन जाते हैं ना इसमें, सो दैट्स वाई इट इज आयोनिक बॉन्ड. एंड the compounds which are formed by these ionic bonds are called ionic compounds. Okay, these bonds are called ionic bond and the compounds are called ionic compounds. Okay, मेटल्स एंड नॉन मेटल्स ही होते हैं जनरली जो आयनिक कंपाउंड्स बनाते हैं, ना कि दो मेटल्स या दो नॉन मेटल्स आपस में आयनिक कंपाउंड्स नहीं बनाते. इसके बाद इसकी कुछ प्रॉपर्टीज़ है आयनिक कंपाउंड्स की. जैसे फर्स्ट ऑफ ऑल आयनिक कंपाउंड्स आर फाउंड इन सॉलिड स्टेट. जैसे तुमने NaCl तो घर पे देखते ही हो, जो टेबल सॉल्ट होता है दैट इज सॉलिड स्टेट, एंड दे आर क्वाइट हार्ड. ओके, दे आर ऑल्सो ब्रिटल. अगर तुम उसका जो पूरा क्रिस्टल लेते हो बड़ा सा और उसको हैमर थ्रू से तोड़ना चाहते हो तो वो टूट जाते हैं. ओके, दे आर ब्रिटल इन नेचर. देन आफ्टर मेल्टिंग एंड बॉइलिंग पॉइंट्स आर हाई in ionic compound because they are attached with each other by electrostatic forces. That means that is a very strong force, so there to break them very high temperature is required, so their melting and boiling points are very high. Then after, these compounds are also called electrovalent compound. देखो electrovalent means इलेक्ट्रॉन की या तो कमी है या एक्सेस है. ओके, and soluble in water. You can see NaCl is soluble in water, but if you are taking another solvents like kerosene, benzene, petrol, okay, pyridine, but they do not dissolve in such solvents. One more thing, these compounds are good conductor of electricity, but that is possible if and only if they are either in the molten state, okay, or they are in the aqueous form. Because अगर वो सॉलिड स्टेट में होते हैं, इन दैट केस देयर आयंस कैन नॉट मूव एंड इलेक्ट्रिसिटी रिक्वायर्स आयंस टू मूव. ओके, सो इसमें से इलेक्ट्रिसिटी कब कंडक्ट होगी? वेन एवर दे आर इन मोल्टन स्टेट. मोल्टन स्टेट में क्या होंगे? जो आयंस है दे कैन ईजिली मूव, बट इन एंड ऑल्सो इन द एक्वस फॉर्म आयंस कैन ईजिली मूव. ओके, इन द एक्वस फॉर्म दे बिकम्स like we are taking NaCl, it becomes Na positive and Cl negative. It dissociates into Na positive and Cl negative whenever they are in the aqueous form. Okay, aqueous. So in that case क्या होगा? Na positive and Cl negative both will act like electron charge carriers. Okay, or you can say electricity carriers or current carriers. So याद रखना, ये भी बड़ा important part है कि जो ये होते हैं आयनिक कंपाउंड्स होते हैं, वाई डू दे नॉट एबल टू कंडक्ट इलेक्ट्रिसिटी इन केस ऑफ सॉलिड. ओके, या और इन द सॉलिड स्टेट, बिकॉज देयर आयंस कैन नॉट मूव इन द सॉलिड स्टेट, सो दे आर नॉट अ गुड कंडक्टर ऑफ इलेक्ट्रिसिटी इन दैट केस. बट इन केस ऑफ molten or aqueous form they are very good conductor of electricity. That's all for today. Thank you.